In a library in Naples, there is a shelf of objects that look like nothing at all. They look like lumps of charcoal, like something raked out of a fire and left to cool. Each one is a book, a Greek book rolled shut that no living person has ever read. They have been shut for more than 19 centuries, and for 250 of those years, the only known way to read one was to destroy it. This is the story of how that stopped being true. It begins with a mountain. Vesuvius stands on the Bay of Naples. On its western shore, 4 miles from the summit, was a small and extremely wealthy Roman town called Herculaneum. About 5,000 people lived there. It was not a city. It was a place you went to get away from one. In the year 79, the mountain erupted. Almost everyone has been told the date, the 24th of August. It is on the plaques, it is in the textbooks. It is probably wrong. The people excavating these towns keep finding autumn, heavier clothing, autumn fruit, wine jars sealed for the season, a coin that cannot have been struck before the middle of September. The current reading of the evidence puts the eruption on or after the 17th of October. The most famous date in Roman history appears to be a copying error, repeated for centuries. The date survives because of one line and one letter, written by Pliny the Younger a generation afterwards and copied by hand for 1,000 years before anyone printed it. Copy a number often enough, and it stops being a number and becomes a fact. What happened next is better understood than the date. Pompeii to the southeast set downwind. It was buried slowly, over hours, under falling pumice and ash, about 4 meters of it. Herculaneum was upwind. Almost nothing fell on it at all. For most of that first night, the town was simply dark and covered in a dusting. Then, the column collapsed. What came down the mountain was not lava. It was a pyroclastic surge, a ground-hugging cloud of ash and volcanic gas, moving faster than a car, at around 500 degrees Celsius. It reached the town in minutes. Studies of the remains suggest that anything above about 250 degrees killed people within 10 kilometers instantly, before they could react, before they could move. There was no running. That is the thing the evidence keeps insisting on. Whatever people were doing, they were still doing it. For a long time, it was assumed that Herculaneum had emptied. The town seemed empty of the dead. People must have fled to the sea and got away. Between 1980 and 1982, excavators reached the ancient shoreline and opened the stone boat sheds along it. They found more than 50 skeletons at once, then more. In 9 of the 12 vaults, they eventually counted 296 people, and the total from the shore now stands at around 340. They had not escaped. They had gathered at the water to wait for boats, and the surge arrived first. And then the town was buried, not under 4 meters, as at Pompeii, under about 20. Surge after surge, through that night and into the next day, each one laying down another layer and each one arriving hotter than a kiln. When it stopped, the shoreline had moved. The sea was now 400 meters further out, and the town was inland and underground. That difference is the whole reason this story exists. Pompeii's ash was comparatively cool and porous. Organic things in it rotted, leaving cavities in the hardened ash, the famous voids that were later filled with plaster to make casts of the dead. Herculaneum's covering was hotter, and it sealed. Wood did not rot. Rope did not rot. Bread did not rot. There was no oxygen to burn them and no air to decay them. Instead, they carbonized. They turned to carbon and held their shape. It is the same process that makes charcoal, heat, something in the absence of oxygen, and it does not burn, it converts. Everything volatile leaves. The carbon skeleton stays exactly where it was. Beans, shutters, a baby's cradle, loaves of bread with the baker's stamp still legible on the crust. And in one house, on the slope above the shore, a room lined with wooden shelves. On the shelves, rolls of papyrus. Papyrus is made by laying strips of a river reed side by side, crossing a second layer over the first, and pressing them until they bond into a sheet. Sheets are pasted end to end and rolled. A Roman reader held the roll in the right hand, and took up the reed part with the left, which means the end of the book finished at the center of the roll, the most protected place in the object. Remember that. It matters later. Nobody knew it was there for another 1,671 years. In 1750, farmers digging a well outside the town of Resina struck something hard at depth. It was marble. The land belonged to the King of Naples, Charles VII, and what followed was not archaeology. It was mining. A Spanish military engineer, Joaquin de Alcubierre, drove tunnels through the volcanic rock in search of statues for the Royal Museum. A Swiss engineer, Carl Weber, followed him and did something unusual for the time. He drew maps. The conditions were appalling. The tunnels were hot, unventilated, and full of gas from the lamps. Men worked them in shifts, in the dark, 20 meters down, shipping through rock as hard as concrete. Weber's plans are how we know the building's shape. His tunnels ran through a very large seaside villa with a colonnaded garden and a private library. The house is now called the Villa of the Papyri. Its owner may have been Lucius Calpurnius Piso Caesoninus, the father-in-law of Julius Caesar. That identification is likely, not certain. In 1752, the tunnelers began pulling out the black lumps. More than 1,800 of them, and at first they threw them away. Picture that for a moment. Men working by lamplight in a tunnel, filling baskets with what they believe is rubbish, and carrying out of the ground the only library to survive intact from the ancient world. They took them for charcoal, fuel. Some were reportedly used as such, some were broken open out of curiosity, which is how anyone noticed there was writing inside. It was the king's minister, Bernardo Tanucci, who told him the lumps should be studied rather than burned, which raised the question that would occupy the next 2.5 centuries. How do you open a book made of charcoal? The first answers were brutal. Camillo Paderni, who ran the Royal Museum, sliced scrolls lengthwise, copied whatever text was exposed on the cut face, scraped that layer off, and copied the next. It worked, in the sense that text came out. Hundreds of scrolls were destroyed doing it. Everything not on the cut face was lost. This was not vandalism. Paderni was doing the only thing that produced results, and he knew what it cost. He wrote about the ones that fell apart in his hands. In 1756, a Vatican conservator named Antonio Piaggio proposed something gentler. His machine glued a membrane to the outermost layer and lifted it away by silk threads, a fraction of a millimeter at a time, using hanging weights. It worked. It was also almost unbelievably slow. The first scroll took him 4 years. And it still destroyed things. The outer wraps, the beginning of every book, came away in pieces. And because a Roman roll ends at its core, what the machine took first was the outside, which is where a book begins. Then came the chemists. In 1819 and 1820, Sir Humphry Davy, one of the most celebrated scientists in Europe, brought chlorine gas to Naples and applied it to the scrolls. He partially unrolled 23 of them. The results were poor, and the chemistry did further damage. By the end of the 19th century, a rough count had emerged. Of the scrolls recovered, a large number had been opened. Many of those had been ruined in the opening, and several hundred remained rolled, intact, and unreadable. Most are still in Naples. 6 went to Napoleon and are in Paris at the Institut de France. A handful are in Oxford at the Bodleian, and others elsewhere, gifts from a king who had more of them than he knew what to do with. What the opened ones contained was, frankly, a disappointment to a lot of people. Everyone had hoped for lost Greek tragedy, lost books of Livy, the missing plays. What they got over and over was Philodemus. Philodemus of Gadara was an Epicurean philosopher who lived in Italy in the 1st century before Christ, and who appears to have assembled this library himself. Around 1,000 of the scrolls carry his work. Epicureanism is routinely caricatured as the pursuit of luxury. It is closer to the opposite, a school arguing that the good life comes from moderate pleasures, close friendship, and the removal of fear, particularly the fear of death. A working philosopher's collection, in other words. Not a royal showpiece, somebody's actual shelf. It is the only library to survive from the ancient world still standing in its own building. And several hundred of its books were still shut. The modern attempt to read them without opening them starts with light. Beginning in 1999, a team from Brigham Young University photographed the already open fragments in many narrow bands of light, multispectral imaging. They finished in June of 2011, having digitized around 1,600 papyri. One band did something remarkable. In the infrared, at about 950 nanometers, the charred papyrus and the carbon ink reflect differently. Fairly differently. But a camera does not have to be impressed by a difference in order to record it. Text that had been invisible for 2 centuries simply appeared. But that only works on a surface you can see. It does nothing for a scroll that is still rolled. For that you need to see inside, and to unroll it in software. Brent Seals, a computer scientist at the University of Kentucky, had spent years on exactly that problem. His method has 3 stages. Scan the object in 3 dimensions with X-rays, find the rolled up sheet inside the scan as a surface, and computationally flatten it. Then find the ink on that flattened surface. In 2016, his team used it on a Hebrew scroll from En-Gedi, and recovered the opening chapters of Leviticus from a lump nobody could open. In 2018, he showed it could work on a Herculaneum papyrus, P.Herc 118. The hard part was the 3rd stage. Hebrew scribes used ink with metal in it, which glows in an X-ray scan. The Romans at Herculaneum used carbon black, soot, and water. A lamp soot scraped from a wick mixed with water and a little gum. Cheap, permanent, and, for this purpose, catastrophic. Carbon ink on carbonized papyrus. In an X-ray scan, the writing and the page are very nearly the same substance. Nearly. The ink sits on the surface and changes its texture by a minute amount. Too little for a person to see. Not too little for a machine to learn. It took an outsider to notice. In the summer of 2023, an engineer named Casey Hanmer was scrolling through the raw, flattened, scanned surfaces, not looking for letters, just looking, and saw a faint crackle in the texture. A dried, cracked film, the way mud cracks as it dries. And in places, the crackle made letter shapes. He posted it. He won $10,000 for it. And a student on the project's chat server read the thread and started training a model on exactly that pattern in the evenings after class. In March 2023, SEALS, together with Nat Friedman and Daniel Gross, put the scan data on the internet and offered $700,000 to anyone who could read it. They called it the Vesuvius Challenge. Anyone could enter. This is the part that is easy to skip past. The data was not held back for a paper. It was published immediately to strangers. A few hundred people with graphics cards and spare evenings did in 18 months what a closed laboratory had not managed in 20 years. On the 12th of October that year, Luke Ferreter, a 21-year-old computer science student, trained a model that found a single word on an unopened scroll. The word was ka, codiferous, porphyros, purple. In February 2024, Farrator with Yusef Nader and Julian Schilliger took the grand prize for recovering about 5% of a single scroll, around 2,000 characters of Greek. 3 people who had never met, in 3 countries, each solving a different piece. One finding the ink, one tracing the sheath through the scan, one reading it out. Nobody had read those words since before the eruption. They concern music and food and how the senses respond to them. Philodemus again on pleasure. And then, on the 25th of June 2026, the thing that had been the point all along, a scroll catalog P.Herc 1067 held by the National Library of Naples, was scanned at the European Synchrotron in Grenoble and read from end to end, not a fragment, the whole surviving roll, nearly 1.5 meters of papyrus, 22 columns of Greek. It is not Epicurean. It is Stoic, a treatise on human nature, impulse, and moral progress dating to the 2nd century before Christ, and it names Aristocreon, the nephew of the philosopher Chrysippus, which is a small shock. This library is the Epicurean collection. Stoicism was the rival school, the one that argued virtue was the whole of the good, and that pleasure was beside the point. A rival school, on the same shelf. Somebody in that house was reading the opposition. The scans, the reconstructed surfaces, and the transcription were published openly, so that anyone can check the work. Here is what makes this worth sitting with. The scroll was never opened. It is exactly as intact today as it was the day it came out of the ground. The reading did it no harm at all. It went back into its box. It can be scanned again in 20 years, with better instruments and read better than we read it now. 250 years of clever, determined people destroyed hundreds of these books trying to get at what was inside them. Paderni's blade, Piaggio's threads, Davy's chlorine. Every one of those methods was the best available at the time. Every one of them was a trade, some text, in exchange for the object. The trade turned out not to be necessary. It was only ever necessary given the tools, which raises the obvious and slightly uncomfortable thought about everything else we have already opened. There is one more thing. The Villa of the Papyri has never been fully excavated. Weber's tunnels mapped part of it in the 1750s. Work resumed in the 1980s and 90s, and again from 2007, but most of the building is still under 20 meters of rock. Ancient houses of this kind commonly held their libraries on more than one level. The room we found may not be the whole collection. Nobody knows what is on the lower floors. It may be nothing. It may be another room of shelves. Excavating it is genuinely difficult and genuinely contested. Digging into a site like this destroys the layers you dig through, and the argument for waiting is the same argument this whole story just made. The tools keep getting better. What has changed is that we no longer have to destroy it to find out. The library burned without burning. It waited 19 centuries. And it turns out it was never really shut, only waiting for us to learn how to look. Thanks for watching.